Good morning, this is Test Sensei, Mr. Spensei, and this is a test review for describing data. It's fairly long, so we're going to break this into multiple videos. Which of the following describes a continuous variable? All right, so let's talk about continuous. Continuous means it can take on any fractional value. So continuous is any fractional value, whereas discrete would be numbers like 1, 2, 3, 4, 5, 6. So in this case, we're looking for continuous. Well, the number of items sold, well, you can't sell 1.5 items, you sell 1, 2, or 3. So this is a discrete, and we're looking for fractional, so that's not it. The number of apps, once again, the key word here is number for both of these. Number of apps, you don't download 2.3 apps. You either download 2 apps or 3 apps. So this is also discrete. The diameters of tree trunks. Well, you could have a tree trunk that's 1.234 inches or 5.67 inches. So this looks like my answer. This looks fractional. The number of baskets, once again, the key word here is number. So this is discrete. The shoe size is once again discrete. All right, because you can have a size 6, 7, 8, 9. So that's also discrete. So our best answer choice is C. Data will be collected on the following variables. Which variable considered discrete? All right, once again, we said discrete are numbers that we can count. 1, 2, 3, 4, 5, 6 are not fractional values. The height of a person. No, you can be 6.2 feet tall. So this is fractional. So that's not it. That's a continuous. The weight of a person, that's fractional or continuous because you can weigh part of a pound. The length of a person's arm, anything that's a measurement, all measurement is going to be continuous. So if it's a measurement, it's continuous. And we notice that above because diameter was also a measurement. So that's fractional or continuous. The time it takes, time is a measurement. So it's also fractional or continuous. The number, oh, there's the key word, number. So that means we're numbering 1, 2, 3, 4, 5, 6. So that is, in fact, discrete. Number 3, data were collected on the 100 United States coin minted in 2018. Which of the following represents a quantitative variable for the data collected? All right, so quantitative mean it's a number. Categorical or qualitative means, oh, we're talking about color or things like that. So the type of metal used, you know what? That's a qualitative. That's not quantitative. That's categorical. The value of the coin. Well, guess what? A coin can be 5 cents, 10 cents, 25 cents, a penny, 50 cents, a dollar. So that looks pretty good. That looks like that's our answer. The color of a coin, once again, as a categorical or qualitative data. The person depicted, that's not a quantity, that's not a number measurement, so that's not it. And the location. Oh, location is not quantitative, that's not a measurement. So remember, quantitative is a number or measurement, something along those lines. All right, which of the following questions about cars in a school parking lot will allow for the collection of a set of categorical data? How many blue cars? We're talking about the number. So that's possible, but we're talking about the number when it says how many. So I'm going to think that's probably not it, but I'm going to put a question mark. What are the gas mileages in miles per gallon? Once again, we're taking a measurement or a number. So this is definitely a quantitative. So that's not it. What are the weights? Oh, weight is definitely a quantitative because it's a measurement, so that's not it. What is the number of cars in a lot with out-of-state license? Once again, um, we're looking at, although um, we're looking at out-of-state licenses and in-state licenses. So that's questionable because it has the word number, so it's possible. It's possible, just like this is possible. Let's see if we have a better answer. So this is possibly a categorical because we're talking about license plate. Um, and then, so it's possible, but we're talking about numbers. So I'm going to say, yeah, that's quantitative because it's talking about a number. And what are the colors of the car? Ooh, this has nothing to do with numbers. This is purely my best categorical. Although this one mentions color, it says how many, so it's talking about a number, so that's not my best answer. And remember, sometimes we're looking for the best answer. This says number, so it's quantitative. So color is purely categorical. There's nothing about numbers on it. All right, moving on to number 5. In a certain school district, from grade 6 through grade 12, students from grade 6 through grade 12 can participate in a school-sponsored community service activity. The following bar chart shows the relative frequencies of students from each grade who participate in the community service activity. All right. Now, if this is in percentages, this is 10%, 20%, 30%, 40%, 50%, 60%. We don't know how many are in each grade. There might be 1,000 here and only 50 here. We don't know how many are in each grade. We just have the percentages. So what is supported by the bar chart? The greatest number of participating students was in grade 9. No, the greatest percentage. So if this said percentage, this would have been true, but we don't know the number, so can't say that. The number of participating students in grade 6 was equal to the grade number participating in grade 7. No, the percentages are the same, but we don't know how many because we don't know how many people were in 6th grade and 7th grade, so that's a no. The relative frequency of all participants in grade 6 and 7 combined was 0.6067. You cannot add across bars. You can say 30% of grade 6 and 30% of grade 7, but I can't add these two together. That's not possible. Grade 12 had the least relative frequency. Yeah, they definitely had the smallest percentage. That's my answer. All right. And it says grade 11 had the greatest relative frequency. No, grade 9 had the greatest relative. So this, if this has been 9, is true, but because it's 11, it's false. So our best answer for 5 is D. Number 6, a sample of 100 students from Liberty High School and a sample of 60 students from Central High School. So I'm going to make a note here. 100 for Liberty, 60 for Central. Were asked what they plan to do after graduation. Responses fell into 5 categories: 4-year university, community college, join the workforce, join the military, or undecided. The results are shown in the table below. So this is Liberty and Central. So I'm going to put L, C, L, C, just so I don't get confused. All right. Which of the following statements, and by the way, once again, we're dealing with relative frequency. So we're dealing with percentages, 5%, 10%, 15, but we don't know how many were in each bar, except we have 100 students from Liberty and 60 students from Central. So maybe we can figure some stuff out. For the 4-year, for the category 4-year university, the number of students from Central High School was 10 greater than the students from Liberty High School. Gosh, I don't know. Let's figure that out. So we look at 4-year. Well, 4-year, we have Liberty at 20%. Percents always go over 100, so 20 over 100 equals, and this is just because this is the percent, equals X over the total. So let's multiply the diagonals. And we go 20 times 100 divided by 100. And we come up with, okay, X, this is for Liberty. So Liberty had 20. When we go to Central, we go, okay, what does Central have? Central had 30%. So 30% over 100% equals Central over, how many are in Central? 60. So when I go 30 times 60 divided by 100, I end up getting 18. So no, The number of students from Central was 10 greater. No, the percentage was 10 greater, but the number was actually less. At Liberty High School, more students selected a four-year university than any other activity. Well, I can sit there and go, well, that's at 20%. And no, more people chose community college. So that's false. 20% chose four-year, 30% chose community college. So that one's false. For the category join the workforce, the number of students from each school was equal. All right, so the workforce here, but they have the same percentages. Well, guess what? Having the same percentages doesn't help me out here because we have different values. We have 20% for each. So 20% out of 100% equals L over 100. That's for Liberty. And when we multiply that, we've already done that above. We end up getting 20 because we multiply the two numbers on the diagonal, divide by the third. For Central, it's 30%. Oh, excuse me, 20% over 100% equals Central over 60. And I go 20 times 60 divided by 100, and I get 12. Well, 20 and 12 are not the same, so that's false. Part D. At Central High School, the same number of students selected for university and military. So at Central, we go, okay, four-year was 30, military was 20. So those are not the same. Because the percentages aren't the same, they definitely can't be the same since we're comparing the same school. And we could check that out if we weren't sure. We could go, you know what? 20% over 100% equals Central over 60. And the other one will be for the military. Oh, I should have chosen, this is 30%. I'm sorry. This is 30%. This is 30% because it's 4-year. And if I go 30 times 60 and I divide by 100, we find that 18. So 18 chose the 4-year. And at the military, we go 20 over 100% equals C over 60. And 20 times 60 divided by 100 equals 12. So 12 chose the military. All right. For the category undecided, the number of students from Liberty High School was 4 greater than the number of students from Central High School. So undecided, let's look at it. Well, they have the same percentages, but actually, what does it mean in the way of numbers? Well, we have 10% over 100% equals L over, there's 100 students. Multiply 10 times 100 and divide by 100, I get 10. So Liberty is 10. When I try Central, it's 10% over 100% equals Central over 60. And 10 times 60 divided by 100 equals 6. And yes, Liberty High School was 4 greater. So our best answer choice was E. All right, moving on. Number 7. The following bar chart shows the relative frequency. So once again, we're dealing with percents. And this would be 100%, 75%, 50%, 25%, 0. Frequency of days of rain for 30 days in 4 regions. So we have 4 regions, A, B, C, and D. This has about 60%. This one has about 27%. I don't know, call it 30%, and call this about 73%. Which of the following statements is not supported? So we're looking for a false statement, okay? Region D had the greatest percentage. That's true. That's not what we're looking for. Region B had the least percentage. That's true. That's not what we're looking for. Region A had 15 more days of rain. Well, I don't know. Let's see. Region A had more than 15 days of rain. Well, we're looking at 30. Well, we know this is over 50%. I don't know what it is. Let's call it 60%. So 60% over 100% equals how many days were they? And this is for region A over 30. So multiplying the two numbers on the diagonal again, 60 times 30 divided by 100 equals 18. So region A is 18. All right. So we know that this is also a true statement because it has more than 15 days. Region C had more than 25 days. Well, region C, maybe that's 30%. So let's put 30%. Let's use a different color. 30% over 100% equals C over the 30 days. Well, when I multiply, I go, well, 30 times 30, the two numbers on the diagonal divided by the third gives me 9. That's not more than 25 days. Matter of fact, if I made that 60%, it's not even going to get there. So there's no way that that's going to be a true statement. So that is false. Okay. And then it finally asks region D has less than 23 days. Well, when I look at region D, I'm sitting there going, you know what? That's about, I don't know, let's call it 70%. So 70% over 100% equals D, and the number of days was 30. Multiply those two numbers, 70 times 30 divided by 100 equals 21. All right. Region D had less than 23 days. Probably so. If we put in 75%, just in case, 75 times 30 divided by 100, 22.5. So even if you took it all the way to 75%, we know it's less than 23 days. So that's also a true statement, and that's not what we're looking for. Our best answer was D. Number 8, the following bar chart displays the relative frequency of students by grade level when asked, do you volunteer in a community service activity? Okay. So once again, we're dealing with percentages, 20%, 40%, 60%, 80%, and 100%. All right. Notice each bar goes to 100% because it's a segmented bar chart. Which of the following statements is not supported? So because the word not, we're looking for false statements. That's what we're looking for. More than 60% of both 10th and 11th grade students responded yes. Well, when I look at that, it's like, that's probably about 75 and 75%. So that's a true statement. So that's true, but we're looking for false. 12th grade students had the least percentage responding yes. Yeah, the black is the yes, and so that's true as well, and we're looking for false. Less than 40% of students respond of 10th grade, so we're looking here, responded no. I'm looking at this, I'm going, maybe 25%, so that's a false. The number of 10th grade students responded yes was greater than the number of 9th grade. We don't know how many 10th graders or 9th graders. So the problem is the number. Because we're working with percentages or relative frequency, we can't say the word number. So the answer to number 8 is D. All right, number 9. A group of middle school students asked which school subject was their favorite. The results are shown. Okay. So we have grade 8 and 7. So I'm going to go ahead and label these so I don't get confused. 8, 7, 8, 7, 8, 7, 8, 7, 8, 7. Okay. And so here we have a number. We're no longer working with the relative frequency. We're working with the actual frequency. So which of the following statements is supported? For students who chose art, the number of 8th grade students was at least 100% greater than the number of 7th grade students. So let's take a look at that. So here, for 8th grade students, Oh, and this says is supported. So we're looking for true statements this time. So when I look at this, I go, you know what? That's 20 students. This is 10 students. So this is about, I don't know, 18. We'll call this 18. And we look at this and this is 10. So maybe that's about 7. Well, 7 times 2 is 18. So yeah, I mean, 7 times 2 is 14, and that's less than 18. So yeah, there's more than twice as many. 100% is twice as much. So this one, there's twice as many eighth graders taking art or chose art as their favorite as seventh graders. All right. Another way to look at it is go, well, we need to be 100% more. That means twice as much. So twice as much. 2 times 7 is 14. 14 is less than 18. That's a true statement. We're done with that one. All right. Number 10. A group of first grade students were asked to name their favorite color. The responses are shown in the following frequency table. Okay, so we have a frequency here. Which of the following statements is supported um, by the frequency table? So what is true? These are actual values. These are not percentages. So the first question, more students chose purple than any other color. No, they chose blue. So that's false. Don't want false. Twice as many chose blue as chose red. Well, 2 times 15 equals 30. So 15 students, so 15 students chose red. Blue was twice as often. That's a true statement. We're done there. Number 11. The following data were collected from a random sample of people on their favorite types of leisure activities and their age. The results are shown in the two-way table below. Okay. What proportion of the people aged 13 to 18 gave watching TV um, as their favorite type? So all we cared about was what proportion of the people aged 13 to 18 so it's going to be intersection over the total. Well, how many do we have in the group of 18? 1,300. And they preferred watching TV. That's my intersection. So 100 out of 1,300. All right. And that's what we have here. 13 to 18. And remember, this is and for intersection. Intersection are where the two streets cross. Okay. All right. This concludes this video. Hope to see you on the next one. Good luck studying.